Data protocols. So reliable data transfer protocols, they are RDT1, RDT 2.0, RDT 2.1, RDT 2.2, and then finally RDT 3.0. Right, so we had discussed about FSM also for all these RDTs. Now let's continue with the performance of RDT. Now we'll see whether this RDT 3.0 has high performance or low, or if there are any issues with this RDT 3.0, we will have to go for the next improvised version of the protocol, reliable data transfer protocol, right? So we will see what are the drawbacks of this RDT 3.0 or what are the drawbacks of this RDT protocols. Okay, yes, we will just start here with one diagram, okay, flow diagram. We'll just see here the stop and wait operation of RDT 3.0. So what is the stop and wait operation? As the name itself indicates, the sender will send the data and then stop until the sender receives an acknowledgement, right? So here the sender will send the data and stop. After stopping means here the sender will have to stop until the acknowledgement is received for the previously sent data, right? So waiting is happening for the acknowledgement, and stop here indicates that stop sending the new data, stop sending the second data. Already first data is sent, stop sending, don't send the second data until the acknowledgement for the first data is received, right? Okay, so you can just see here the sender is sending the first packet, and how the packet is sent here, can you see the line here? It is thick line, thick green line indicates that the packet is sent not at just in a bulk or something, or it is not sent as a burst there. The packet is sent bit by bit, or you can say if the packet has, say if the packet contains 1 byte is equal to 8 bits, right? So if the packet size is just 1 byte, then the packet is transmitted bit by bit. All 8 bits are not transferred at once, so one by one the bits are transferred, right? So you can just see sender is sending the data if the first packet is sending, and if the packet size is 1 byte, at time t is equal to 0, you can notice here at time t is equal to 0, the first bit of the first packet is sent. The first bit of first packet is sent, and at time t is equal to 1, at the very next instant here, after time t is equal to 0, the very next instant, the next bit, second bit of the packet is sent. Likewise, all the 8 bits are sent one after the other, right? So after 8 milliseconds okay, you can just see here, if I am measuring the time in terms of milliseconds, maybe after 8 milliseconds the first byte of data is transferred. Okay, so this is how the sender is transmitting the data. All 8 bits, if this packet size is 1 byte, all 8 bits are not transferred at once. Bit by bit the packets are transferred, and you can just see here the receiver is receiving the packets. Receiver is receiving the first bit as it arrives, then the second bit as it arrives it accepts the packet, then third bit. So all the bits of the first packet, if the packet contains 1 byte, all 8 bits are received one after the other, and receiver will be sending back the acknowledgement only after the last bit of the packet is correctly received. Okay, after the last bit of the packet is correctly received, the receiver will send the acknowledgement back to the sender. So here the sender is stopping, that is the sender stops sending the data, or the sender will not send the next new data until the acknowledgement is arrived. And you can see here the acknowledgement is arriving. Immediately after the acknowledgement arrives, sender will start sending the next packet, or the first bit of the next packet is sent over here. Okay, so all these measures, about all these measures I will just discuss here. Okay, so what is this basically called as? The sender sending the data and the receiver sending the acknowledgement. The time taken, the total time taken for this entire process, you call it as round trip time. So what is a round trip? One way from sender to receiver, and one more way back from receiver back to the sender. This completes one round trip, right? So round trip time, you can call it as the time taken for the packet to transmit from sender to receiver, and the time taken by the acknowledgement to travel back from receiver to the sender. This total time taken by both packet, acknowledgement packet as well as data packet, this total time taken, you call it as round trip time. So this completes one round trip time, right? So there is some duration here. What is that? The packet will take certain amount of time to travel from sender to receiver. Again, our acknowledgement packet also will take a certain amount of time to travel from receiver to sender. So this total time taken we have to measure here. Apart from this time taken or the time spent in journey, apart from this, there is also some amount of time taken by the packet or by the sender to transmit the packet, like how we saw here. The entire packet is not sent at once. The packet is transferred bit by bit. So there is some time taken at the sender side to transmit the entire packet. So here, whenever you're calculating round trip time, you have to compute the time taken by the sender to transmit the packet first, right? So that time taken should be added with the time taken by data packet to travel from sender to receiver. So that is the time taken by the packet to travel from sender to receiver. After that, there is some time amount, there is some time here again, time taken by the acknowledgement packet to travel from receiver to back to the sender. There is some time spent over the acknowledgement packet, so to travel from receiver to back to the sender. So this entire duration you have to add up, and that forms, or that is the final round trip time. Okay, so that is the packet from the sender side. For the packet to prepare the packet at the sender side, there is some time spent. Add that time spent with the traveling time. So what is traveling time? The time taken by the packet to travel from sender to the receiver. This traveling time is also added. And finally, the time taken by the acknowledgement packet to travel from receiver back to the sender. This traveling time also is added. So all three durations you add up, and that forms one round trip time. Okay, right? So we will discuss about this again with the help of an example. So we'll just go back to the previous slide. You can see here. Okay, let us consider a link here, and the link capacity is 1 gigabits per second. So what is the link over here? You can see here the link between sender and receiver. This link we call it as you can call that link as the one transmission medium. You can just call it as a transmission medium which is developed between sender and receiver, which is present between sender and receiver, over which the packets are transmitted. The link is the one which is connecting sender and receiver for transmitting data packet as well as the acknowledgement packet. So that link also has certain capacity, what you call it as bandwidth, right? So that link capacity you call it as you consider it as 1 gigabits per second. What is the meaning of that? For every 1 second, the link can transmit up to 1 gigabits of data. That is 10 to the power 9 bits for every 1 second can be transmitted over the link between sender and receiver. So you can just see here the link capacity we have taken as 1 gigabits per second, and here you also have some amount of delay. So what is this delay? It is 15 milliseconds. What is the meaning of delay? It is nothing but the time taken by the packet to travel from sender to receiver is 15 milliseconds over the link. Right? So over the link, the time taken by the packet, it is the journey time of the packet from sender to receiver. And what is that journey time, or the time spent by the packet in traveling, is 15 milliseconds. So it is just one-way journey from sender to receiver. Same amount of time is also taken by acknowledgement packet to travel from receiver back to the sender. So that is the journey time, or the time spent by acknowledgement packet, that is from receiver back to the sender. Okay, so that particular journey time is also 15 milliseconds. I'm sorry. Yes, so the total time taken now by the packet, data packet, as well as by the acknowledgement packet is 15 milliseconds plus 15 milliseconds, and that is 30 milliseconds from sender to receiver, back from receiver to sender. It is total 30 milliseconds of time that is spent, and you can take here, consider here. So 15 milliseconds is a propagation delay from sender to receiver, plus 15 milliseconds is a propagation delay from back from receiver to sender. Total 30 milliseconds of delay you have over the link. And here there is a packet whose size is 8000 bits. Packet size is 8000 bits, right? Okay, so with these three measures, we will just start calculating the total transmission time of a packet. So what is total transmission time? The time taken by the packet to travel from sender to receiver, and the time taken by the acknowledgement packet to travel back from receiver to sender. So that is the total transmission time. We will compute that transmission time. Yes, so how to compute the transmission time? We'll just see here. Over the link whose capacity is 1 gigabits for every 1 second. Okay, so we will just first compute what is the time taken by this packet whose size is 8000 bits. What is the time taken by this packet to travel over the link? So what is it? The time, we will compute the time taken by the packet whose size is 8000 bits. What is the time taken by the packet to travel over 1 gigabit per second link? So the link whose capacity is 1 gigabit per second, over that now you are supposed to transmit the packet whose size is 8000 bits. We will just compute the time taken by the packet to travel over the link whose capacity is 1 gigabit per second. So how do you compute that? It is something like this. See, for every 1 second, the link can transmit up to 1 gigabit. 1 gigabit means 10 to the power 9 bits. For every 1 second, 10 to the power 9 bits can be transmitted. So what is the time taken by this 8000 bits to transmit over this link? So here, what is the time taken by this 8000 bit packet to transmit over this link? So cross multiplication. So 1 second, for every 1 second, 10 to the power 9 bits can be transmitted. For 8000 bits, what is the time duration? So cross multiplication is how much? 8000 divided by 10 to the power 9. So total time taken by this packet is 8000 bits by 10 to the power 9 bits. So how much is that? 8 microseconds is the time taken by this packet to transmit over the link whose capacity is 1 gigabits. So it is 8 microseconds. So you can take this packet size as L, denote it as L, and the link capacity you can denote it as R. So L by R is the total duration, that is the time taken by this packet to transmit over the link whose capacity is this, right? So it is 8 microseconds. You can just see here. It is 8 microseconds, just 8 microseconds taken by the packet, by this packet whose size is 8000 bits. Now we will compute what is the actual utilization of the sender. So what is the meaning of utilization, sender utilization? Sender utilization is what is actually the time spent by the sender here. So what is the time spent by the sender here in transmitting this packet whose size is 8000 bits, right? So the actual time spent by the sender here for transmitting the packet is how much? So what is it? How do we compute it? Yes, so we just came to know that for transmitting this packet whose size is 8000 bits, the time taken by the time actually spent for this packet is how much? 8 microseconds, right? So it is 8 microseconds is the time spent by the spent for this particular packet. But you know that the propagation delay for every packet, what is the meaning of propagation delay? For the packet to travel from sender to receiver and for the acknowledgement to travel from receiver back to the sender, that is called as propagation delay. And that propagation delay is fixed between sender and receiver. And how much is that propagation delay? It is 15 milliseconds from sender to receiver plus 15 milliseconds from receiver back to the sender. 15 plus 15 is how much? It is 30 milliseconds. So 30 milliseconds is the propagation delay for any packet it may be, right? So 30 milliseconds is the propagation delay, or you can also call that propagation delay is how much? What? Round trip time. So one round trip time is 30 milliseconds. But you know that But you know that this, apart from this 30 milliseconds, you also know that it is 8 microseconds, that is the time taken. 8 microseconds is the time taken by the packet to transmit. Or you can say here, with the help of a diagram, if I'm explaining, you can just see the sender is transmitting the packet not at once, right? It is transmitting bit by bit. So for the complete packet to transfer, that is from 0th bit till the last bit, if the packet size is how much, 8000 bits, we have just taken the packet size as 8000 bits. So from 0th bit of the packet to 7999th bit, that is total 8000 bits. So 0th bit to 7999 bit. So till that, the time taken by the sender to prepare the packet before transmitting, the time taken by the sender to prepare the packet to transmit, or the total time taken by the sender to transmit the last bit from 0th till the last bit is how much? 8 microseconds. So 8 microseconds. So you can just say that now total utilization, sender utilization is actually 8 microseconds for sending the packet from 0th till 7999. So after 7999 bit is transmitted, total 8 microseconds is spent by the sender. And you can see here, sorry, let's just go back. Yeah, you can just see here 8 microseconds. You're going to add up with what? The total propagation delay. What is propagation delay? The sending time 15 milliseconds plus the acknowledgement time. Acknowledgement time is again 15 milliseconds. So 15 plus 15 is 30 milliseconds, plus you add up with the sender's time. The time spent by the sender in preparing this packet, preparing the packet to send. So send total packet size of the packet that is sent is 8000 bits. The time spent to send the packet, complete packet, is 8 microseconds. So add up that 8 microseconds with the total propagation delay 30 milliseconds. So 8 microseconds when you add with 30 milliseconds, that is actually the total time spent by the packet. Total time spent by the packet, right? But you know that the actual time for the sender, spent by the sender, is how much? 8 microseconds. If I'm converting that 8 microseconds to milliseconds, it will be something like 0.008 milliseconds. This is the actual time taken by the sender for sending the packet. Divide that with the total time spent by this packet to travel from sender to receiver and the acknowledgement from receiver back to the sender. How much is that? Round trip time 30 milliseconds. Add up with the time taken by this packet to travel, that is time taken by the sender to transmit the packet. How much is that? 0.008 milliseconds. So 0.008 milliseconds add up with 30 milliseconds, the propagation delay, that is 30.008. You can now call this as the utilization, actual utilization of the sender. That means the link utilized by the sender, whose size is 1 gigabits, that is 1 gigabits link is actually utilized by the sender for only how much duration? It is only for 0.00027. That is, you can say it is only for this duration the sender has actually utilized the link. You can see here 0.008 milliseconds is the time spent by it is the actual time taken by the packet for transmission. Out of 30.008 milliseconds, only 0.008 milliseconds is actually utilized. And you can see the sender is utilizing only 0.00027. If you are converting it into percentage, it is only 2.7% of the link, is utilized by the sender. Right? So sender is utilizing only 2.7% of the link. But what is the link capacity? Actual link capacity 1 gigabits. So 1 gigabit is 10 to the power 9 bits is the link capacity. So out of this 10 to the power 9 bits link capacity, only 2.7% of the link is utilized by the sender, which is very, very less. You can utilize up to 10 to the power 9 bits. Right? So utilization is very, very less. How to increase the utilization? Whether we should increase the utilization or not? Yes, of course, we have to increase the utilization of the link. So how to increase the utilization of the link? See, more the link is utilized, You can say maximum data is transmitted between sender and receiver. So more the link capacity you utilize, maximum is the amount of data that is transmitted. So you have to always try utilizing the link more and more. So how to increase that? For that we have a concept called pipelined protocols. So what is this pipelining concept? So far we have seen the stop and wait policy. What is stop and wait policy? We have seen that only a small amount of data is transmitted. Only small amount of data is transmitted. That is, only one packet is transmitted between sender and receiver at a time. But instead of that one packet, can we send multiple packets at a time? So this concept we call it as pipelining. So instead of sending one packet at a time, like here how we were doing so far, one packet is transmitted over a time. Instead of that, multiple packets can be transmitted between sender and receiver, right? So there is definitely drawback here also when you're sending multiple packets, but at the same time, by doing this, we are utilizing the link more and more. We are utilizing the bandwidth of the link more and more. We'll see now how the multiple packets are transmitted between sender and receiver. We have two protocols for that. One is go back N protocol and the other one is selective repeat protocol. So this go back N protocol is the one wherein you can see the multiple packets are transmitted between sender and receiver. Similarly, in selective repeat also we can see there are multiple packets that is transmitted between sender and receiver. So each of this protocol we will see in detail. Okay. Yes. So you can just see here the overall concept of pipelining. You can see it's not just one packet that is transmitted. Back to back multiple packets are transmitted. We will see how the multiple packets are transmitted here or how it increases the utilization. We will just see. See, the sender is transmitting the first packet here. At time t is equal to 0, the first bit of the first packet is transmitted. And after this first bit is transmitted, at the next instant of time, next bit is transmitted. But remember, all these bits are belonging to which packet? The first packet. And now you can see here, the first packet is transmitted. Here you can see a black line which indicates that it is the end of first packet. So first bit of the first packet is arriving at the receiver, and here the last bit of the first packet is arriving at the receiver. And immediately after the last bit arrives, after the last bit of the first packet arrives at the receiver will transmit the acknowledgement back to the sender. You can see here, after the last bit of the first packet is received, the receiver will be sending the acknowledgement. You can see here. Yes. Similarly, the second packet also starts. The second packet is sent here. After the last bit of the second packet is arriving, the acknowledgement for the second packet is sent. Similarly, the third packet, the last bit of the third packet, once it arrives, the acknowledgement for that particular packet also will be sent, right? So 3 acknowledgements for 3 packets, right? You can just see here, all the packets are sent back to back. Here, the first 3 packets are sent back to back. Here, you are not waiting for any acknowledgements until the third packet is sent. So after third packet is sent, the sender will wait for the acknowledgement to receive. You can see here the acknowledgements. Once the acknowledgement is received for the very first packet that was sent, immediately fourth packet is sent from the sender side. Immediately after the second packet, acknowledgement for the second packet is received, the sender prepares for sending the fifth packet. Similarly, when the sixth packet is sent, after the acknowledgement for the last packet sent is received, the acknowledgement, the sixth packet, the last sixth packet is transmitted from the sender to receiver. Okay, so this is how the transmission of multiple packets are transmitted from sender to receiver. Okay, so this is how you can see. By doing this, you can see the sender's utilization is increased. How is it increased? Instead of sending one packet at a time, sending of one packet at a time is denoted as L by R, but here you are sending 3 packets at a time, which can be denoted as 3 into L by R. So 3L by R divided by, so this propagation delay, denominator remains the same. It is how much? 30 milliseconds, which should be added with the individual packet delay. So individual packet, time taken by individual packet is 0.008 microseconds. That is one and the same. 0.008 milliseconds, I'm sorry, that is one and the same. So 30 plus 0.008 is one and the same. That is the link capacity or the propagation delay, which is added with the individual packet time taken by individual packet. So now you can see the numerator only is changed. Instead of one packet, you are now transmitting 3 packets. So the sender utilization is increased. Earlier it was 0.00027, but this time it is increased to 0.00081. So 8.1% of the link capacity is utilized now. So 3 times the link capacity, 3 times the sender utilization is increased, right? So when you're sending 3 packets at a time, 3 times the sender utilization is increased. So this is actually the advantage of pipelining, increasing the utilization. Okay, so you can just now go to the actual 2 protocols what we have here, which is implement